So yesterday we went on Cutie Pie, the unfortunately named Cutie Pie's misadventures with trying to get her CD published or her CD recorded. So today we're going to take the next step on that, and we're going to talk about the different types of solutions. And we kind of already did talk about them, but I want to summarize what they look like just so that you know if you see a table, you know what you're looking at. If you see a graph, you know what you're looking at. If you see an equation, you know what you're looking at. So here's what we're going to start. We're going to start with the graph. Okay, so the first situation with one solution was this one up here with Cutie Pie. Okay, when we look at the graph, we have, and I'm going to use my two highlighters just so that I can see that there are two different lines. And all I'm going to do, literally all I'm going to do is I'm going to draw two lines crossing. It doesn't matter where they cross, you're going to draw two lines crossing. And we're going to write cross in exactly one place. So they intersect or cross in exactly one place. Okay, so both of these lines, and that point is right there. That's where they cross. Okay, now let's think about what a table would look like. So in our case, when we had that table, we could make some values. So let's take a look at this. I'm going to put some values in this table, and I'm just going to pull them right off of the graph. Okay, so when I look at, actually, I'm going to use my calculator. When I look at my calculator, oh, my battery's low. It's very upset. Okay, when I look at my calculator, if I put in the quadrant music, so 2x plus 1, well, I'm sorry, 2x plus 1, and I go to the table, I'm looking, so the solution was 4, 9. And actually, what I'm going to do is I'm going to show you, I'm going to graph both of these at the same time. So I had y equals 2x plus 1, and I had y equals x plus 5. When I look at the table, and again, I know yours doesn't look exactly the same as mine, but when I look at the table, it's very, very hard to read. You see there's exactly one row where y1 and y2 are the same. Okay, and what that means is that when x is 4, both lines are y1 and y2 are equal to 9. So let's kind of sketch that. So what I saw in the calculator, first of all, I'm going to have 3 rows. Now, it is possible that they will give you 2 tables. So let me erase this. I'm going to show you because there's something that we see a lot and y'all kind of don't know how to handle it. So in the calculator, we would see x, y1, and y2. But what we might also see is we might see 2 tables. So they might give me a table like this. They might say like 2, 3, 4. And they might say 5, 7, 9. And they might, over here on this table, the x and y might be 4, 5, 6. And they'd say 9, 10, 11. Okay, so for this one, what they're wanting you to identify is that both of these guys have a row 4, 9. That means that's the point that they have in common. The intersection is 4, 9. Okay. Now, this is what you might see if they give you 2 tables. They might also give you like the table. So let's just draw a little thing here, and I'm going to do this as small as I can. X, y1, y2. You might also see like this. 5, 7, 9, 11, and then that, which is what we have in our calculator now. Okay, and then what they're asking you to do is look for the row where y1 and y2 are equal. Now, a big mistake you guys make is you're like, oh, there's 2 9s. That must be, no, it's, and then I'm gonna write this for you kind of like darker so you can see it. Then it becomes an ordered pair. 4, 9. Okay, let me zoom in a little bit, because by zoom in I mean let me put the camera a little bit closer. Do you see what I mean? So the x and y1 turn into an ordered pair. I don't care if x and y1 are the same. I care that y1 and y2 are the same, and this right here is the reason I know it's my solution, because this x value has the same y. They have the same xy coordinate. Okay, now for an equation, okay, if I this is what we've seen up until now. So I want to show you what it looks like when you get a solution, an equation that has one solution, okay? So I'm going to solve this. I'm going to subtract 1x from both sides. I get 1x plus 1 equals 5. I subtract 1 from both sides, and I get 1x equals 5. So x equals 5. And that's how I can, wait, I'm sorry. Yeah, guys, did you know that? No, Angie. Sit down, Angie. X equals 4. I lied. Okay, so that's how I know to go look. And so then what I would do is I would put this in my calculator, and I would go look at 4 and see if I had the same thing for y1 and y2. Or I would put this in y1 and that in y2. We're going to be doing a lot more of that strategy. We're not just solving. Okay? For a system, we have an extra step, but we're not there yet, so we're not going to worry about that right now. Okay. Okay, so that was our solving systems. That was what a system looks like when we have, I can't zoom out. I just tried to zoom out by scrolling like I do at school. That's what happens when we have one solution. We're going to see one value. We're going to see x equals something. We're going to have one row. So right here, we're going to say one row where y1 equals y2. Okay, only one row where y1 equals y2. And then we're going to have x equals a number. Okay, x equals a number. Okay, now let's talk about no solution. All right, for no solution, what we're going to see when we graph it, do your best, is we're going to see parallel lines. So do your best to draw a pair of parallel lines. And so parallel lines never cross. And because parallel lines never cross, we will not have a solution to this. Okay? For the table is a little trickier. So I'm gonna have us write this down, and then we're just gonna be looking at what it looks like in the calculator. It's a little trickier with the table because I'll just show you why. So no y1 is equal to a y2. So no y1 and y2 are equal. You never see a row where y1 and y2 are equal. y1 and y2 are the same distance apart. Okay, so let's talk about what that means. We're going to put the two equations from this. We had 3x and 3x plus 4. So we're going to put those into our calculator. Okay, I know you're upset. Okay, so we had 3x and 3x plus, 4. Okay, now when I look in the calculator, so in previous years we've talked about how we've talked about how no y1 equals y2. Okay, but we need to take it a step further than that, because it's possible no y1 and y2 will be the same because we just can't find them. We just don't see them yet. Okay, I mean, maybe the y1 and y2 that make this inequality true are like negative 8 million. Maybe it's 46,000. Maybe it's a decimal, and our grid thing isn't showing us that. So what we're looking for, so let's write down some values. Let's just do -1, 0, and 1. So I'm going to actually move my thing here so that it's easier for me to find that. Okay, so for y1 I have -3, 0, and 3. For y2 I have 1, 4, and 7. Okay, so what we're going to look for here, ooh, that was kind of smooth, go me. Okay, what we're going to look for here is y1 the same distance from y2? So I don't like that -3. What 0 plus 4 equals 4. What does 3 plus 4 equal? 7. What does -3 plus 4 equal? 1. Do you see how these are all the same distance apart? That means they're not getting closer or further away, which means they're parallel. Okay, this is what parallel lines look like in a calculator. So again, we don't just want to look for y1 and y2 are not equal, because again, we may just not have found it. What we want to look for is, are they the same distance apart? 3 plus 4 is 7, 6 plus 4 is 10, 9 plus 4 is 13. Do you see how they're all the same distance apart? 21 plus 4 is 25. It doesn't, no matter what points I look at, 9,015 plus 4 is 9,019. It doesn't matter what points I look at, they're always going to be 4 apart, and that's what makes this parallel. Okay, so when we solve this equation with no solution, if I subtract 3x from both sides, because I'm trying to move all my x's together, they both zero out on both sides. So that leaves me 0 equals 4, which is not true. Okay, so what this means is I have number equals number, but it's false. Okay, I get number equals number, but it's false. So just like with inequalities, when we had a number greater than a number and that was false, that would be no solution. Okay, let's take a look at the last one, which is infinitely many numbers. Now for the graph of infinitely many numbers, we had two lines graphed on top of each other, so they're kind of like we're graphing them simultaneously. So what we're going to see, and again, this is kind of hard to do, but like I'll see one line and then I'll see another line graphed right on top of it. So again, almost like a double shaded line. And then when I look at the points on that line, every single one of them is a solution. So I have nothing but points that are the same. So yeah, so what does that look like in a table? So what this looks like is all y1s equal y2, okay? I mean, and like literally there's nothing else to add. So let's put this in our calculator and let's see what we get. Okay, so the equation, again, with cutie pie here, we had 4x plus 1, and well, I'm going to put the other one in because like it's not always that obvious. So we had 4x plus 1, and then when I wrote this equation, there was a materials fee of $6 plus $4 per song minus a $5 discount. And I know I have them in the wrong ones, but that's okay. Whoops, didn't mean to do that. But you can actually see it happening here. Look, it's graphing the red line, and now you see it graphing the black line right on top of it. When I look at the table, and actually really quick, I'm sorry, let's write that down. One line graphed on top of the other. Okay, now for this one, when I solve it, again, I'm going to start by combining like terms. I have positive 6 and negative 5. 4x plus 1 equals 4x plus 1. Okay, so I'm starting to see already that I got the same thing on both sides. If I subtract 4x from both sides to get my x's on the same side of the equal sign, I'm left with 1 equals 1, which is true, right? So then my definition of infinitely many solutions would be, I have number equals number, and it's true. Okay? And I never did tell you, I'm sorry, I never did do this. Oops, sorry. So for the table, I had x, y1, y2, right? And when I look, they're all the same. So if I had at 0, y1 is 1, y2 is 1. At 1, y1 is 5, y2 is 5. Okay? At 2, y1 is 9, y2 is 9. That's supposed to be a line. They're always equal, my y1 and y2. So that means everything. So this is why, you see how up here we said only one row? This one, if you see one row, that doesn't mean it's the solution if every row is the solution. Does that kind of make sense? All right, you're going to practice now.